All right, let's do our science lesson. I'm going to make this a little bit bigger. Whoa, that was the opposite of bigger. Let's just do this. Okay. States of matter. Moving somewhere out of the way.
Welcome to the lesson, What are the states of matter? We're going to learn about solids, liquids, and gases.
Actually, I'll just go away.
We will also learn about how they are similar and different. The vocabulary words for this lesson are solid, liquid, gas, evaporation, and condensation. Click each word to find out more about it.
So I'm pretty sure that you guys in second and first grade and probably kindergarten have learned already about the differences between the solid, the liquid, and the gas. The two newer words that may be newer to third grade are evaporation and condensation. I want you to stop and think. Have you ever heard of the word evaporate before? Have you heard about water evaporating? Let's see what it says. The process by which liquid water changes into water vapor. See, watch this, watch it happen. The water is out on the pavement, but it's evaporating. The puddles are evaporating and turning into a gas. So evaporation takes the water and turns to the liquid and turns it into a gas. Okay, let's look at condensation. I think maybe it's a similar word, but it's maybe a different part of the process. Let's see. Oh, this is when water vapor changes into liquid water. So, do you think condensation is the opposite of evaporation? Do you think they're opposite processes? Yeah. All right, let's see what else we can learn in this lesson.
It's hard to believe that this tower of ice is the same substance as the liquid water below it. Did you know that ice takes up more space than liquid water? Like all matter, water has three states: solid, liquid, and gas. Click each picture to learn more about each state. Solids, like these ice cubes, have a definite shape and volume. Volume is a measure of how much space matter takes up. By looking at these ice cubes, it is clear how much space they take up.
So a solid ice cube, you can tell how much space it takes up. You could even measure it with a ruler before it started to melt. Let's see about these guys.
These liquids have different shapes. That's because liquids take on the shape of their container. Like solids, liquids have a definite volume. They do not have a definite shape.
So that's the difference between liquids, well, one difference between liquids and solids. Solids and liquids both have a definite volume, a definite measurement of how much stuff there is, but a solid has also a definite shape, okay? Now, if you threw the ice cube, if it wasn't melting, if you threw the ice cube out in the cold where it wouldn't melt, it might land on a different side, but it's still going to be the same cube shape. If you threw a thing of liquid into a bowl, it would take the shape of that bowl or of our little containers over here. Let's find out about gases.
Do you see the steam coming out of the kettle? That's a sign that water vapor, a gas, has been produced. Gas is the third state of matter. Gases do not have a definite volume or shape. Although you can't see gases, the steam tells you that a gas is in the air. The steam forms when invisible water vapor, a gas, condenses to form tiny water droplets.
Oh, did you hear that word, condenses?
When you breathe and your lungs fill with air, that's another sign that a gas is present.
Okay, so a gas does not have a definite shape or a definite volume. Just kind of floats around. All right, let's see what this one does.
Because gases spread out to fill space, they do not have a definite shape or volume. However, they can be squeezed or compressed into a container.
Just like if you ever had a helium balloon and the way it floats up in the air, that's because there has been some helium, a gas, squeezed inside of that container and then a knot tied in the bottom of the balloon to keep it in. That's why when you pop it, all of the gas shoots out. Come on.
Matter
There we
can
go.
change from one state to another, but certain conditions must be in place. Click each picture to find out what happens.
Okay, let's start up here.
At 100 degrees Celsius, water boils. Have you seen bubbly hot water boiling on the stove? Boiling water is changing from a liquid into a gas. Liquid water does not have to boil to become a gas. Water from a pond and sweat on your arm can become a gas without being 100 degrees Celsius. When liquid water becomes a gas below 100 degrees Celsius, it is called evaporation.
Okay, so when the liquid water turns back into a gas, and so it looks like the water just floated up into the air in gas form, that's evaporation. And you can kind of hear it in the word evaporate, vap. Do you hear the same as, does it look, take a look at the word evaporation. Do you see, I wonder if I can highlight this. No, it won't let me highlight it. Do you see the word vapor, V-A-P-O-R, inside of that word? So it's the water turning into a gas. Water vapor is the gas. Okay, liquids.
Gas changes back into a liquid when it cools. This process, the opposite of evaporation, is called condensation.
So the opposite of evaporation is condensation. So they're the same process, they're just going in different directions.
Do you think that liquid water can change into a solid? If you said yes, you're right. Water freezes when it cools down to 0 degrees Celsius. As ice warms up, it melts at 0 degrees Celsius and becomes water. You've just learned about solids, liquids, and gases. Now take a look at these objects. Can you put them in the right category? Drag each picture to where it belongs.
Okay, let's see. The house, solid, liquid, or gas? What about the juice? Yep, it's taking the shape of its container there. Good. What about this Windex, this glass cleaner? Yep, that's a liquid. What about, I don't know if that's showing the tree or the air. I guess it's showing the tree. A penny. That's a solid. You see the steam coming out of the water that's boiling? That's showing you the gas. You see that you can't see the air inside the balloon, but you can see that the balloon is filled with it because it's holding that shape. And what are these guys? More liquids, taking the shape of their container.
You got it! A tree, a house, and a coin are all solids because they have a definite shape and volume. Juice, oil, and window cleaner are liquids. They take the shape of their containers, but they have a definite volume. And gases, like the helium inside this balloon or water vapor from a pot of boiling water, spread out to fill their containers because they do not have a definite shape or volume.
For some reason, I'm having to try 2 times.
What will happen to this flavored water? Click the statement that answers the question.
Okay, where are they putting it? Do you know what that is? Do you see the cube trays? That tells me they're probably putting it in the freezer. Okay, does the freezer make things very, very cold or very, very hot? Yep, very, very cold. So it's flavored water right now. So it's a liquid. It is going to turn into a solid, and that is the process of freezing.
That's correct. When liquid water is cooled to 0 degrees Celsius, it will freeze and become ice. If the ice is heated, it will melt. Can you name how water changes? Match the process to the sentence that best describes it.
Okay, just like freezing and melting are opposites, evaporation and condensation are opposites. The only difference is freezing and melting have to do with the change between liquids to solids. Evaporation and condensation has to do with the change between liquids and gases. See the difference? All right, so freezing is water changing to ice or ice changing to water? Yep, water to ice. What about melting? Melting is ice changing to water. That's easy. You know this stuff already. Those two tricky words are the ones that try to trip you up. Evaporation. Oh, remember that word vapor inside evaporation? So that means it's turning into a water vapor. It's turning into a gas. Look right there. Water changes to water vapor. Evaporation. And by the process of elimination, we can tell that this one is condensation. And it is correct. Water vapor changing into water. Gas to water.
Great job! You matched the process with its description. You've learned a lot about water and how it changes from one state to another. Before we finish, let's take a quick look at the main points you covered. Matter commonly exists in 3 states: solid, liquid, and gas. Solids have a definite shape and volume. Liquids take on the shape of their container, and they do not have a definite shape. Gases do not have a definite volume or shape. Can solid water change to a liquid? Yes, as ice warms up, it melts to become a liquid. Water freezes when it cools down to 0 degrees Celsius. It becomes a solid. Water can evaporate to become a gas. Gas changes back into a liquid when it cools. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
Okay, so now that you've watched the video, I want you to pull out your Science and Social Studies file and take out, it says, what are the states of matter? Lesson 5 right here. You see her eating her popsicle. Okay, I want you to look through this lesson on your own. It's going to talk about some of the same things that we just talked about, but it's just going to put it in a little bit different ways. And sometimes, like for me, sometimes watching a video helps me learn, but reading it and maybe taking some notes on the paper really helps it stick into my brain. So I would like you to do both, but you don't have to like spend a whole long time on this because this is just telling us some of the same things we've already learned, sort of like a review. When you get to the end of the packet, you don't have to do all the writings on the inside. None of that. You can if you want to, if that helps you remember it, but you don't have to. What I want you to do is on the back. This page says "Sum It Up." It is page 124, and it is a matching. So you have to look at the picture, see what's happening, and draw a line to whichever one matches what it's saying, okay? So for instance, what's happening in this bottom picture? Can you tell? Okay, I am seeing steam come up out of the liquid water as it cooks. And you know what? I think I see the answer right next to it. I might be giving you, oh, I'm sorry, I'm having trouble keeping it straight because the thing is backwards. I might be giving you a quick little answer. Except no, I was looking at it backwards again. So let's see. During this process, is it a liquid changing to a gas or a gas changing to a liquid? Draw a line to whichever one you think matches up, okay? I think you'll be able to see that better if I'm not trying to go back and forth. So do that one on your own. Let me know if you have any questions. Take a picture of this when you're finished with all the X's so I can tell what's matched to what. Also, if you're having trouble making the lines look nice enough for me to read them, it's also fine for you to just write, like see how there's a letter in each box? It's also fine for you to just write the letter right here or even over here beside the number. That's fine. As long as I can tell which one goes with which, we're good. Okay, that's one part. I want you to also do the crossword, which is this little extra bonus paper. It's not in the packet. It should have been right behind the packet, okay, on its own. I want you to do the word play crossword, And I want you to do